When I count inversions in a permutation, I usually use the code. But there's two more ways to do this, and I wanted to look at those a little more closely. So just to remind you how the code works, if we have a permutation W and Sn, we define the code of W, so it'd be the word C1 through Cn, where Ci equals the number of letters to the right of Wi and smaller. And of course, as we've been using to count inversions, if we add up all the elements of the code, we get the number of inversions in W. Now there's another way. This is looking at all the inverted pairs from the point of view of the left larger number. We could also look at things from the point of view of the right smaller number. So alternatively, define the inversion table of W to be the word A1 through AN, where AI is the number of letters to the left of I and greater. So this is not exactly the reverse of the code, because here we're looking at the letters to the right of what's in position I and smaller. Here we're looking at letters to the left of actually the letter I and greater. So for example, let's look at 423615. So the code is to the right of 4 and smaller, there are 3 things. To the right of 2 and smaller, there's 1 thing. To the right of 3 and smaller, there's 1 thing, 2, and then 0, 0. And if we look at the inversion table, we find the 1 and say there's 4 things to the left of it and greater. Then we look at the 2, there's 1 thing to the left of it and greater. We look at the 3, there's 1 thing to the left of it and greater. 4, nothing to the left of it and greater. 5, there's 1 thing to the left of it and greater. And 6, there's nothing to the left of it and greater. So this is also what I call a substair word, because the first letter is somewhere between 0 and n minus 1. That happens if the 1 is in the last position. It'll have n minus 1 things to the left of it and greater. Then the second letter is between 0 and n minus 2, because this corresponds to the letter 2. And the maximum number of things that could be to the left of 2 and bigger than it is the number of letters that are bigger than it, which is n minus 2. Similarly, this is at most n minus 3, n minus 4, etc. And then we always end with a 0, because the number of things to the left of and greater than the largest letter is always 0, because it's the largest letter. So this has that same property as the code. And I call it a substair word because I imagine this sitting underneath a staircase. So 5, 4, 3, 2, 1, 0. Let's make this staircase that goes up to 6. And so if we put this 4, 2, 3, 6, 1, 5 in it, then 3, 1, 1, 2, 0, 0, 3, 2, 1, 2, 0, 0. So why do I have too many stairs here? Oh, actually this is already good because we don't need 6 in the first column. So if we're working with S6, that first stair can be 5. So we have 3, 1, 1, 2, 0, 0 fits underneath the stairs, just like if we look at the inversion table, 4, 1, 1, 0, 1, 0. So 4, 1, 1, 0, 1, 0 fits underneath the stairs also. Now we can also count inversions by using the permutation matrix. Let's use 4, 2, 3, 6, 1, 5 as an example again. Now this is a permutation in S6, so I need 6 blocks in each row and column for the matrix. Alright, then we'll write the ones in 4, 2, 3, 6, 1, 5. Maybe I'll put those in black so they're easier to see. Four, 2, 3, 6, 1, 5. Alright, so that's the permutation matrix. Then we're going to put a dot in every cell that has a 1 to its right and a 1 below it, like here. So there's a 1 to its right and a 1 below it. Here, this has a 1 to its right and a 1 below it. This does 2 and that does 2. All of these do because these all have 1s to the right and this one below it. Then this position has a 1 to its right and a 1 below it. This position has a 1 to its right and a 1 below it. I guess that's it. So then we count the dots and we get the number of inversions. So we have 3, 6, 7 dots. That should give us 7 inversions. And if we add the components of the inversion table, that's 7, 4 plus 1 plus 1 plus 1. If we add these, that's 5 plus 2, which is 7 also. So they're consistent. So the rule for placing these dots is so in the permutation matrix, P of W, place a dot in each cell having a 1 to its right and a 1 below it. And then just count the dots. And that is the number of inversions. The end.